All right, today we're looking at the ratio and root test. We're going to start with the ratio test, or the root test. The root test is used whenever you have something to the nth power and it's not a geometric series. Now, we don't want to use it for a geometric series, even though we could, because the geometric series, we usually want to find what it converges to as well, and so we want to use a geometric series test. But the idea is if we do the absolute value of the sequence and then take the nth root, now the absolute value just means getting rid of the alternating part, and do the nth root, and then the limit as n goes to infinity. If that limit is less than 1, the series converges. Greater than 1, it diverges. Equal to 1, it's an inconclusive test. All right, so you'll see things like this, where you end up with having n in the exponent, but it's definitely not a geometric. So we'll try the root test. Limit as n approaches infinity of the nth root of e to the 2n over n to the n. Limit as n approaches infinity. Now the nth root is the same thing as saying to the 1 over n power. Now when you do the 1 over n power, that's a power to a power. That means we're multiplying. So this becomes e to the 2 over n to the 1. And now as n goes to infinity, this goes to 0, which is less than 1. So the series converges by root test. Now the big thing with this is you don't want to forget about your other tests, because a lot of people, they're going to see the n to the power and they're going to say, okay, that's what I have to use every time. But for example, one like number 5 here, if we try and do the root test, even though it looks like a root problem, we have limit as n goes to infinity of nth root 2 to the n over 2 to the n minus 4. Well, on the numerator, it's not an issue. That's 2 over, but on the denominator, you can't distribute a power. You can't just distribute in the 1 to the n, 1 over n there. So you'd have to go through a full L'Hopital's rule, because you get infinity to the 0, which is one of our indeterminate forms. So you'd have to move it up to the top, put a natural log to bring down the power, to get a L'Hopital's rule, to do the division. It's just a long process. When if we had thought about this for a little bit longer, we could see, oh, this is just an nth term test. Limit as n goes to infinity of 2 to the n over 2 to the n minus 4. If we divide everything by 2 to the n, then all of the sudden, we now have something that as n goes to infinity, it equals 1, which is not 0, which means it's going to diverge by the nth term test. All right? So making sure we remember our other tests is super important. To go with that, we also have the ratio test. This one is used for some more complex things where you have mixed values or you have factorials. Those are all things that call for the ratio test usually. Ratio test says we're going to do the limit just like with the root test, but we're going to take the an plus 1 sequence and divide it by the an sequence and then do that limit. The conclusions are still the same. If the limit's less than 1, it converges. Greater than 1 diverges, equal 1 inconclusive. So a good one would be something like this. The nth power up here makes you think it might be a root test, but the factorial makes it a ratio test. Ratio test is going to be much better there. So we're going to do limit as n goes to infinity of 2 to the n plus 1 over n plus 1 factorial times, well, let's do divided first. Divided by the original sequence, 2 to the n over n factorial. Now, when we divide by a fraction, that's the same as just multiplying by the reciprocal, so we're going to say just times n factorial over 2 to the n. So we want to simplify these. To make it a little clearer for you, I'll line them up. 2 to the n plus 1 over 2 to the n times n factorial over n plus 1 factorial. 2 to the n plus 1 over 2 to the n, when we simplify that, just gives us a 2. N factorial over n plus 1 factorial leaves us with a 1 over n plus 1. Now as n goes to infinity, this goes to 0, which is less than 1. So the series converges by ratio test. Okay. Nothing more complex than that. You can just see different varieties of problems. So let me know if you have any questions. You'll have a great day.